application of technology to solve social issues of Punjab. He also mentors the students in AI and machine learning at Sabud and thereof leverage them to get jobs. He's also an enthusiastic contributor to the Open Speak Net. Dr. Sujit has also published around 65 research articles in various international and national journals and conferences of repute. He is committed to providing strong research experience and technical skills for achieving organizational long-term product-oriented goals. So we are thankful to have you, sir, on this session. So I welcome you again, and I'm handing over the session to you. Welcome, sir.
Yeah, thank you, Sandeep, sir. And it's pleasure to be here and interacting with the participants. And it is always a pleasure to be connected with the faculty and other staff members from Guru Nanak Dev Engineering College and Engineering Fraternity. Thanks so much for your kind words. And I don't think that I'm worth of so many words, but still we can try our best to deliver what we learned over the time. What we believe is learn, educate, and give back to society. And I think that's what is a mantra to Sabud Foundation that you introduced. Thank you so much for your kind words. And hello, participants. This is Sukhjeet. And as Mr. Sandeep has discussed about me, that what I'm doing currently, most of my work is related to spatial data science, where we were working with the spatial analysis. I worked with the Punjab Remote Sensing Center. I worked with the Nokia Maps. And also, while I was working as a data scientist with Velocity Technologies, we worked with the various utilities like Hydro One and other utilities to build a IoT device that's smart enough to basically connect the customer with the utility. So there was a spatial component in that. So I was working over that. So coming to my discussion for today is, if I think my screen is visible to you and I'm audible to all of you. I hope it is.
Yes, sir.
So we have been discussing about data science, which has two components, data and science. So it comes together, it creates a full pipeline, like how the data would be actually, scrapped, transformed, build model, and, then we get into insights of the data. So data science pipeline is more experience is needed. So if you go to the job market, then there are specialized jobs for each and every component of data science project. So every industry wants to apply AI machine learning, and they want to steer their organization for, some good decisions. So they always employ it. And then the number of jobs those come out of it is data engineering, then ETL processes, then visualization, machine learning, engineer, and then is a data scientist. So data science, if I give interviews, many interviews at Toronto, and what they are doing is they are looking for somebody who is really very good at steering the organization. So they need experienced person is an data scientist. So if you are early into this particular cycle, then you join as a data engineer, or you join as a junior data scientist who would be working on models only. So today I'll discuss another subset of data science, which is called spatial data science, where the importance is for where it is, the location. So spatial data science is a subset of data science that focuses on characteristics of the spatial data. We will work on some sub cases where I'll show you what exactly is the spatial data, and would give you some insight into QGIS and also about how we can implement different regression models onto this spatial data. Why it is important for spatial data is because in GIS or in spatial space, we consider that everything is related to everything else, but near things are more related than distant things. So if I talk about normal data, because you have been through so many sessions now, you know what is the importance of data. So the first job of each and every data science project is to scrap the data, filter that data, analyze that data, and look into the data set. Once you look into the data set, only then you will be able to decide what model is the best model for this particular kind of data set. So we cannot apply each and every kind of model to each and every kind of data. So certainly we need to analyze the data before we actually enter into the normal data set. Consider that all the records, all the observations that we have in our data set, they are not that correlated. But in spatial domain, we say that closely related, whoso are closely mapped, they are much more correlated than the other ones. So that would actually identify the patterns out of the data set, and we can do targeted, uh, add thing. We can do like if I have data which is particularly related to Ludhiana, I know that targeted ad can be done only for the persons who are from the Ludhiana. So we were working on a project where we had a moving car, and over that we had a billboard, a digital billboard, and based on the location of the car and the geographic demographics of the area, the targeted ad was being displayed on that particular billboard. So it's a digital billboard basically. So such things are coming up. The spatial aspect is added to each and every data source or data set we are generating. So starting from your message, starting from your tweet, then when you click a website, then you go some restaurant place, each and everything is being tracked by smartphones, and each and everything has a spatial component attached to it. Now companies are moving toward how they can actually use this information, which is spatial information, from that particular data set. So their spatial data science treats location, distance, spatial interaction as core aspect of data using specialized methods, softwares to analyze, visualize, and apply spatial use cases. So they have wonderful spatial use cases from retail industry to real estate to telecom utility. They have use cases. Now, how they want to utilize the spatial component of the customer that they are tracking. So that makes this field very lucrative. If you go to the market, then you say that, okay, I'm a spatial data scientist, then certainly there would be, a lot many offerings for you which are available, and this is the recent statistic that came is 68% of the organization are going to increase their investment into spatial data science. And if you say that how many are prepared, I would say one out of the three data scientists claim that they are spatial, they can do spatial analysis, but what they do mostly is they consider the lat long available in the data set as a spatial component. But this is more than that, because the spatial analysis is not a new term. It has been there for a long time and was being used by governments, municipal corporation for urban development. But now, as each and every data what we produce over internet in our daily life has a spatial component attached, and companies are looking at that particular data in a big way, and they need special data scientists who can work on this spatial domain. So what are the key skills and technologies you need to know? Python, you're already doing. R has been a pioneer in spatial domain because it's already there. If I talk about data science, it is more like you need not only know about the programming skill, it is also the statistics that you need to work on, which you have already covered in this course. And then you need to know the domain, knowledge domain. I heard it, and with my experience, what I see is if you have a domain knowledge, then it is easy for you to be a data scientist. I interview many data scientists. Those are coming from different domains, not only from computer science, but they see that there are problems that they can use this data science methodologies to solve. So they are becoming data scientists, and they are applying these applications and tools into their own domain. So mostly, if I say, this is just some information which is there for spatial data science, but there are other components which we call big data analytics. This has to be attached, and there are tools out there to do all that computation for large spatial data analysis. Even spatial Hadoop is available. If you have worked with it, SpicePark is available, but still there is a lot to do, and there is so much of space open for this particular area of data science. So you need to know Python. If you are good with R, then it's perfectly fine. And then there are other softwares. One is QGIS. I'll give you brief introduction. Then we have PostGIS. It's a module that would be connected with the PostgreSQL. I think you have heard of it. PostgreSQL is an RDBMS. It's basically an object-oriented database, and it's an open source and being used by industry. So MySQL and PostgreSQL are the databases which are being used by industry, and MySQL is very good at transaction management. But if we want spatial component, then PostgreSQL is the one database that we will be using, along with an attachment of PostGIS. Then we have Carto frames, and Esri is big way in a proprietary space. So they are also QGIS and Esri. They are basically giving their competition to each other. So this is the skill set which you need to do the spatial analysis. I don't want to make you overwhelmed with any of these, but if you know Python or R and PostGIS, the database, then you can start this analysis super easy way. So there are libraries for Python which we can be using, which we can use, like GeoPandas is there. Then we have ArcPy is there, and each company they come up with their own analysis. We have TensorFlow, we have Scikit, we have NetworkX, we have OMX. So there are many libraries out there similarly for R, and then we have different platforms that we can use for spatial data science. Remember, what we say is the traditional data science tools are being used for spatial data science because they consider the lat and log just as an extra variable in the data set, but still there is a lot to do on it. So what type of data, spatial data, is being used? As you know, for data science projects, we talk about we need as much as we can. So there are pipelines, there are different tools which are used for scraping the data. That includes internal data from the organizations. Then there are many open data uh, available these days, which provides you with the demographs. Let us suppose I talk about I have to open a retail store and I want to search out the best location. Then I need different data sets. So I need the internal transactions of the the people, I need their location, I need their demographic information. And there are many agencies out there, those provides a specialized kind of data which we can use for spatial data analysis. So this similar kind is also for data science, but this is what we do for spatial analysis. Now, this is a life cycle for data science project. I hope you are familiar with it, but I just want to quickly go over it. So first we start with the discovery phase. You identify there is a problem that you want to solve for data using AI and machine learning. Then you try to collect the information, whether there's information out there. You look for open source repositories. You look into your organization internal records. Just like if I say I have to do some behavioral analysis of the students, then I need to look into the records, what G and DC have. And based on that, I will look into some other knowledge points so that I can connect them together and say, I have enough data now and I think I can model. Then the next step is the data prep, which we actually do extract, transform, and load. That's ETL. Some call it ELT, also extract, load, and transform, because the big data is there. So it's very tough to actually work on streaming of data. So we put the data into our data lakes, and then we prepare the data set. And then we need to do visualization, which is very important part, because visualization would give us knowledge about and insight about what is happening and what we are collecting. Again, I would reiterate is, if you can live with your data as much as you can, certainly then you will be preparing a better model. So the first part of a data science project is to live with the data, to transform the data, to play around data with a different multi dimensions. I know there are other data mining was already there. So they had first phase of ETL, and they used to do the same visualization, multi-dimensional visualization of data. So when you go to industry, there are many good tools which are available for data visualization. One is Orange. Then we have Tableau is there. Then we have Power BI. So there are a lot many jobs, particularly for business intelligence. If you only do and master those visualization tools, then you are also at the top of it. So you'll be working in the first phase of data preparation and reporting. Then, as a machine engineer, you know that you have this data set. Now you need to plan about the model. You might be knowing that based on the type of the data set, sometimes we need to classify, sometimes we need to cluster, but it's never written in a problem statement. The organization heads, they will ask you, okay, prepare a model. And then you as a machine learning engineer, you need to look at whether clustering is going to be supporting for us, or classification, or regression, or there is any other algorithm out there that you can look at. Regression is mostly applied for when we have to predict something. Predict is your quantitative variable you want to quantify and predict that variable. Then the best way is using regression. So regression, there are books written on it, and there are many constraints that we basically go through for regression. So let us suppose your problem is to identify the the age of somebody who would buy that product. Then you can certainly use a regression model. Clustering analysis normally supports your judgment. Like, as a data scientist, you need to prove and you need to collect the facts that whatever model you are going to use is supporting your facts. So clustering sometimes you use for doing the analysis or pre-analysis and support your judgment what your model is going to say. So normally in When we talk about model planning, so there are many models that we implement, then we compare those models. So in the model building, we build those models, then we compare those model and we come to conclusion that which model is giving us better accuracy, efficiency, and results. So here you can see there are cyclic change. Why the cyclic change are there? Because in data science project it is more agile. You need to go back to the previous states to correct and then come back to the model building again. So this stepping is very much connected. So you keep on doing this again and again till your model is giving better results. Now if I talk about better result, it's not only about that you get 100% of accuracy. That is not the case. You get 100% of accuracy, but you get 90% of efficiency. So
Participant, just wait. I think some problem is there. Just bear with us for 5 minutes. In the meantime, you can fill the feedback. Feedback form for the day 6 is available. I'll share in the WhatsApp group.
yeah, sorry, I think my internet went down. I hope I'm back.
Yes, 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 no problem, sir. No problem.
Okay. Yeah, yeah, yeah. Sorry for that. Okay, so and then we actually communicate our result and operationalize it. So this is uh, the normal life cycle for data science project. How the data science and spatial data science are different, because we say that there are two spatial traits: location, distances, interaction, and how the correlation between the locations. So there are many things that are different in spatial data science from normal data science project. If I talk about spatial data types, so mostly there are, broadly we say there are two different types of data which are available for spatial analysis. One is vector type and other is raster. The vector is the one which we are going to talk today. We have point, line, and polygon. Point is single place, so we call this point of interest. Then we have lines. You might have seen GPS tracks and road, rivers, and contours. All these are line data. So they are basically an array of points together in an ordered fashion. And then we have polygons, which we say is an administrative body, boundaries and buildings. All that is basically used for this kind of data. So these are two. We will be talking about vector type of data in detail today. Then, as we say that spatial analysis need the spatial data, so Earth is round and we need to convert that round data into a two-dimensional computer screen. Then how we do that? There are coordinate reference systems for that, which basically convert a 3D space into 2D, and from 2D to our projection system, which we can use for communication or analysis. Now, in a spatial data model, there are two things. One is geometry, which is most important, plus the properties. Now, in normal data science project, we say each observation would have some properties. But in spatial data model, we have the geometry, and for each geometry there are different attributes those are available. So this is kind of the importance which we have in the normal data science project. They have the spatial component at the end, but in spatial data model we have geometry as a most important part, as along with the properties, which are our attributes for the information. So geometry is a shape, whether it is a point or line or polygon, and property is going to be the attributes. So how we transfer the data, how we communicate the data, there are many formats. So one example is JSON. So as you know, JSON is used to communicate the data over internet. Whatever web information you will extract or scrap, you will get the information mostly in JSON format, because it's lightweighted and XML is outdated. And for geospatial data, we have GeoJSON. So GeoJSON format is used to transfer the data from one place to other place over the internet. Now let's quickly jump over to QGIS. It's an open source geographic information system. It helps us to look at data very quickly and get insights into it. And it helps you to create dashboards and the first level information for the data set. Then we will talk about 2-3 cases. Case 1 is air quality. Case 2 is mapping census data. Then we have case 3 is an Uber movement analysis. And last one is, which I will like to discuss, is building a prediction model based on Uber analysis. Let me quickly go to the QGIS. I hope my screen is visible to each one of you.
Yes, sir, it is visible.
But it's on air quality, correct?
Yes, sir, it is okay. Perfect.
Okay. Okay, so this is QGIS interface, and this software is being used by industry, which they want to do first analysis. So let's quickly jump to the first project where we want to see and manage the air quality of of Delhi. So I'm going to download data which is available from open platform, and this data set would actually, let me just stop share and share again. Yeah, I hope now it's full data desktop coming. So OpenAQ is a platform that collects data, and we are going to scrap this data from there and going to look at the data set of Delhi for it's from yesterday's data. So let me or load this data. So I go to the layer, and this data is in a CSV file, and I'm going to open this data. So it's a delimited text file. So here you can see CSV, comma separated values. It automatically identified this is a point coordinate. It has longitude and latitude. And along with this, here you can see the information is coming. Let me add it. So the data has been added to the screen. So here we can see that this whole is the data of full India. So I have downloaded it, and we will try to analyze for New Delhi. Let me add more value to it. So if I click here, it can show me the attributes which are there for that data set. So location, city, country, UTC is a time. Here you can see lat and long, which are given. So this is a point type of data, and this is visible in our QGIS. So I can make more, data more interactive by doing some styling to this data. So let me do that. So here is my data set. So I open this data, and let me open that. So here's my data set, and I would like to zoom into the certain area. So because the time is less, so I'll try to make it simple and straightforward. So what I did is basically, so once I have uploaded my data set, so based on the styling, I gave the classification. I did the classification of the data. So how that has been done? It's more like GUI based, where I did graduated algorithm selected, which classifies the data based on values, and the parameter that I have chosen is value. So value is a parameter from the data set. I click on this, and then it creates the classes. So here you can see that classes has been created. Now, from this data set, you can also visualize that there are records which has negative value for PM 2.5. This data, this data set, yeah. So,
Participants, please mute yourself.
yeah, I think I need to mute everyone.
It's okay now.
Okay. So you can see that whenever we do the visualization and analysis, the first hand information is to look at the data set. So we looked at PM 2.5, which is a data which we downloaded from Open Data website. And here there are records with negative value. Now these negative values are not correct. It means that our data contains outliers. So first information that is given here, and even you can see that we have a range scale of, 6 from 0 to 500, 700, and 800. But this range is very, very high. So we have cases where there is 7,828.8 is the record for PM 2.5. So these two values are basically suggesting there are outliers in our data set. We can visualize it where they are. So we can visualize where that information is. So certainly we can try to look into it. So there are, sorry. Just a minute, there's a panel on it. So we can visualize these information. Let me again pull everything back. Sorry, yeah. So you can see here are certain points where this red label is too much. So we can always look for where we have bad data. This is one way of doing. So this is a sphere, air quality that is happening, and this is yesterday's data. And we say that the COVID would be very dangerous when we have this sphere condition of the data. So you can analyze it very easily. Just download the data set and bring it into QGIS and then do the analysis and publish your result. And basically, so this is one step. So where you can do, and this is how we interact with the POI, points of data. Now quickly jump over to other project where I want to show you analysis over Punjab. So there are analysis that I have done here to show you guys like how we can do. So this is the census data that I have downloaded. So let me use no symbol here. So this is Punjab data that I have downloaded from census website, available out there. You can download it. And from this, first, what I do is I look at the attributes. So for looking at the attributes, I need to do this. So here you can see the parameters which are available. So this is the first step for each and every data science project. You look at the attributes which are available. So there are many attributes which are available, but you will find the whole sum of information, what attribute says and what value it brings into the data set, why it is being encoded. So once we have the data set, you can color it based on the classes that you want. Let us suppose I want to create, I want to look at the percentage literacy for each and every village. So we have total literacy. Look at the attributes. So we have total population. So what I did is I'm calculating the percentage, and based on this percentage, I'm calculating and going to map and classify my data. So here it is. So based on that, I would like to classify, and you can see my data has been classified based on the information which is available. So what I did is the population which is literated, which is educated, and by divided by the total population, and based on that I created a map, a thematic map, which would actually give me the information where we have the maximum education. Now if I'm launching a product which needs more people who are uneducated, so I know where my targeted sale would cover. So you can see here, uh, here this belt, particularly Malwa belt, we need to cover a lot for educating people. And so this analysis is the first type of analysis that you can do for visualizing what your data is giving you, and based on that you can analyze. So all these graphs are going to support your judgment as a data scientist, because algorithm would be speaking, and you as a data scientist has a responsibility to take the challenge and ask and suggest the management that whatever your analysis is done is 100% correct. So you need many supporting documents for that. So such are these documents. So spatial component would obviously be giving and helping you. Now what I mean to say is, if you can look at here, this whole data is a polygon. So each data is a polygon here. So it's a polygon. We discussed about the points data, we discussed about polygon data, and now let's jump to the other type of data, which is Uber analysis. So here, if you look at it's a third type of project which I'm going to discuss here. So I hope I'm on time, because I got time limit till 3:15, so I try to finish everything. And I would like to create curiosity. Certainly this is a lot more to take, but I will try my best to create curiosity at least, so that you can visualize what we are doing, what we are analyzing, and then we have a language to work on similar kind of analysis. QGIS and ArcGIS, they are leader in visualization of spatial data. So what I'm going to do is, we have Uber movement data out there available for downloading, and would like to actually analyze the traffic patterns and find out the areas those are accessible within 30 minutes of driving. Let us suppose you are trying to open a hospital, and we want that there is an ambulance service, and we want you to tell me how much area that can cover this particular ambulance within 30 minutes. Let us suppose you are going to open a Domino's shop, and I ask you, okay, we have to deliver within 30 minutes. What are the areas we can capture within 30 minutes? So those things are basically called isochrone. Those maps are called isochrones, where we give the start point, and from the start point we measure the time. So you remember the Dijkstra algorithm, so that we use to find out distance between a given point to another point. This is huge and compute intensive, certainly, because you have to do initial matrix formation, but it is very helpful. So if you say about Domino's Pizza, certainly this is their tag value. If they fall back and they do not identify the areas that they can deliver within 30 minutes, then certainly it's a flop show for them. So for such things we can use isochrones. So for that I actually downloaded the data for Bangalore. Why I did that? Because Delhi data is huge, and it was a problem with my computer. So you can download any data based on your performance of the data set, and then computer, and then you can analyze. So first of all, let's look at the attributes which are there. So here you can see we have wards. So each ward is given a name, its movement ID, which is internationally, identifier for each and every data within a country, and then its display name that we are would be using. So here, what type of data it is. Now, the data here is your data here is polygon. So this is again a polygon data which is available. So I did fix it because my time is tight. So I'm not going in detail of how we can fix the data sets if we find. Would like to show you what exactly the other information is. So here is other data that I have downloaded from the website there. So Uber movement would give you the data set which you want. Here are the wards, and here is the timestamp you want to download. Download the data. I download all data. Here you can see that the travel time. Let us suppose we are doing actually one project with a Kal Academy here, Badu Sahab. So they want that they have a fleet of 15 buses, and they want us to optimize their route from the academies to the students. And also if a new student joins, they want that if we can identify what location would be best for the student based on such things. So here are the travel times. So these kind of data set would be very helpful if you want to build such uh, you know um, system, spatial data science project. So certainly you need some data set where you want to get the routing time from a place to another place. You can use Uber data. So we use this a lot. And here is the travel times by hour. So it includes the arithmetic mean, geometric mean, standard deviation of aggregated travel time over the selected date, range between every zone pair in the city. So it is giving the data comparison between the zone to zone. So what time has been taken at what hour of the day. So that information is given. You can download it. Coming back, there are many records. So to cut short, I actually filtered this down to few records. So I think there are around 200 records that I have downloaded, and I take one destination. So the destination here is 193 zone number. So what I did is I tried to find out the distance, the isochron distance uh, from the zone 193 to every other zone, and I want to see how far I can go within that 30 minutes from my zone 193. So that is what we are going to do here. So this is the data which I have shown you. I hope, let me go over again. So source ID is the moment ID from where we started. The distance destination ID is the ID where we went, and the passenger actually moved out of the car. This is the hour of the day, at what hour when this data was captured. Then the mean travel time, mean average time, metric, geometric, standard deviation, geometric mean time, and standard deviation. So these are parameters that you can use to make more graphs, because in data science, the first part is doing visualization. If you do the visualization, you will get to know uh, the data much more quickly than just doing computation. So what we did is actually here I joined two data sets. So one data set is filtered data set by from for a ward, when where the starting point, where the destination is 193, and hour is also matched. I want to see the average travel time from 9 to 10. So it is already matched. So based on that, I'm going to connect these two data sets together. Here is a beautiful component which is attached to QGIS, which empowers this toolkit to do more analysis based on what is already there. So this gives you the power to connect your Python scripts, or as well as your R scripts with it. So if you have any script that you want to do the analysis, you can easily connect that with the QGIS and do the analysis. So here is already built-in scripts that we can use. So here is join attribute by field. So I can connect different, so this is a join operation that I'm going to perform. Now there are two flat files out there, and I want to join them together. There should be a joining field. So based on that joining field, I will join these two types together. So one is the spatial data, another is just a non-spatial data. It is just a tabular form. So based on that, I actually connect these two together, and what I reached at is this. So here you can see that out of this, so what things I have joined is this particular thing. Now let me, I hope it's a bit understandable. I'm not going that far. At least it should be provoking you to do such analysis. My objective is that, so I can filter my data. So filtering that data, I want that the mean travel time should be 30 minutes. So it is given in the seconds, so I give that, and movement ID should be the 193. So when I click on it, so it is showing me that data. So this is what I can reach within 30 minutes from the main Bangalore data. So let me, it's already there, so let me clear it first. So here you can see the total travel time, and based on filtering, I want to see how much I can reach in 30 minutes from my starting location, which is 193. So if I want to change it to 45 minutes, let us suppose 27 seconds here. So this is what I can reach from my zone 193. So these are the places. See, you can see that these are the places I cannot reach within 45 minutes from the place which is here. Let me show you where it is. I think it's here somewhere. So yeah, so it's here. This is the place that is saying that I can reach from this very place to these many places within 45 minutes. And if I want to see, just again do the filtering, and I want to see that within 10 minutes where I can reach is 600. So I make this, and you can see I can reach from this place to only these white areas I can reach within that particular time. So let me extract this information, and here I have extracted already for you guys to look into. And this is for 30 minutes data. So this is for 30 minutes data, and this is what I can reach from this particular place to those areas around. So that can help me actually better urban planning in the analysis. So we can attach our AI machine learning algorithms written in Python or R with QGIS and use its spatial capabilities to do the analysis with spatial things on it. So that's all. Is there any question, or if you have, you can ask now. So and let me. I have 15 minutes more. I'll be respectful to your time. Is there any question? I can see there are questions. Yeah. Okay. Okay. There are no questions. I think I'm going overhead. Transmission is going on then. So, but still, I think that there is a lot that we can do, and yeah. So certainly, if I can show you here, we can create a new scripts. So here you can go and write down the scripts,
Sujit,
and
there are, I think there are two questions uh,
mhm.
by the Rajinder sir. Sir, can you show how QGIS can be used with Python?
So QGIS, we need to actually set up the interpreter path if you want to do. Otherwise, you have they have given a direct editor for Python and for R. So you can directly write those packages. What is like that's a good question. Basically, when we talk about Python, the libraries which are written for QGIS are hosting within this software. So sometimes it depends upon like how we can connect. If you are able to connect it, if you are using your Linux system, it is super easy for you to connect your Python library, any Python interpreter with QGIS, and then you can import it just like other modules which you can do. If you are working on Mac, then you have to do the coding inside QGIS, where you can call all those libraries. My system is new. Otherwise, I myself had many scripts which are written. I could have shown you. Those were more on to routing analysis that I did with the hair maps. So we wanted to identify different quality measures. We wanted to test the quality of the road network. So those were written. We can do that certainly, Rajinder. You can email me anytime. We can set up an extra session for that, and would go over if there is other information needed. And Spatial Light is a DB. It's more kind of a light database where you have flat information available, but just like a JSON format, and you can use it super easy way. So these are the connectors on the left hand side. So different packages, different data sources, different web services. So this WMS is a web service that you can connect. Let us suppose you want to scrap data from Google, or you want to scrap data from OpenStreetMap, which I'm showing as a base map. So those services can be used in a super easy way. So there are ArcGIS and GeoNode. So there are repositories that we can bring in. So this one is flat database, flat file database that we can use there. Like mostly it is used with mobile application. So SQLite is one example. The same way is a Spatial Light for this. Okay, now last part of my lectures discussion is about building a prediction model. So here we are using the same data set where we have Uber movement and we use OpenStreetMap services to calculate the routing distances. Uh, we want to use this Uber data for travel time prediction. I want to go from A point to B point, how much time it will take. So for that, we have built a regression model because it's the quantitative type that I want to figure out or want to predict. So regression model I can certainly use. So there are steps, and I will go over how I have done that in Python. Would not run because it is going to take time, and we have 12 minutes left. So for the spatial analysis, I'm going to use the first thing for any data science project is the data. So there are two data sources that out there that I have used. One is Uber Movement and other is OpenStreetMap. OpenStreetMap, I don't know how many of you are familiar with it, but crowdsourced project. My whole PhD work was focused on OpenStreetMap data. This is public data repository. I compared this, analyzed this data set with other proprietary data sets, and see that the crowd contribution is always awesome and wonderful as compared to that those proprietary highly paid data sources. So OpenStreetMap, if you want to use for any analysis in your life, then you can go over there, you can download this data. If you want to contribute, there are conferences, there is a strong community that would actually help you out to work on OpenStreetMap data. So this data is there. Uber we have discussed already. Then in Python, we have libraries that we can use pandas, and there is a version for it, GeoPandas. Then we have Shapely, Plotlib, and Scikit-learn is for machine learning algorithm. And I hope you have already learned this Scikit. Uh, I'm downloading my data sets here. So I quickly go over what exactly I'm doing. So formulating the problem is the problem statement. I want to go from point A to point B. Now, as a data scientist, the management said to me that build a system. So I started thinking and penning down what exactly I need. I said I need some data set where I can actually find out the travel times, so that those travel times come from Uber analysis. So they give the wards, and within a ward we have to figure out how we can actually map those points and add offset values to those points. So from where I will find the distance between a point A and B. Then there are APIs out there. Normally, if you have worked with the mapping kind of application or mobile development, most of people use Google APIs because they give you the distance metrics from A point to the B point, and based on that return result, you may say that this is what the time would be taken. But if you have to actually implement this predictor, then certainly you need more information. So what I did is first I take the data set. So here is a Bangalore Awards data 2020 for quarter 1. Dates by hour, bucket aggregate is used. So we see that this data type is including source, then destination, month, day, start hour, end hour, mean, travel time, standard deviation, and there are many other basically attributes. So these attributes would be used for prediction. Now, there when we talk about regression analysis, not each and every column is productive for us. So first we build a model, then we look at the p values for each and every column. If they you think that this is good or not, or you do feature engineering. What is feature engineering? You go step movement, you keep on adding the attributes to the model and look at the performance of the model, and then stop where there is no further enhancement into the model building. So there are different approaches out there, but most important, we do the feature engineering. We select certain components and which are available, which are good for us for our model and not. Coming back to my problem is the travel time. I then looked at the travel times. I look at the ward information here. is my, like here now you can see it is multi-polygon, so number of polygons are connected together for building this particular polygon. So this is how I'm showing the whole set. This I have already shown you the Bangalore map data. And then we have data processing. If you need to analyze, you need to see more of the data, there are libraries, but it is super easy to look at such things in the QGIS software. But if you want to add a few things, it is available there also. But if you are hardcoder lover, then you can do all such stuff here too. So here another column has been added for categories to hours, and based on that we actually filter out how much time is taken, and we categorize them into different sections. And then we get day of the work, because day of work is very important in our data set. So because we have taken the quarter, so day of work is very, very important, because our whole regression model would depend upon that feature, what day and what time in the day. So if you search something on Google, they will always show you a hourly map. So what at what hour the wait time is less for particular shopping mall, or the crowd is less. So they have all that. So day of week, a week, as well as the time is also important. This is not a very elaborative analysis, but you can do much more than this. So we have award boundaries. And what we did is, because we want to find out the prediction time from one point to another point, so what we did is we find out the centroids for the wards. So we will try to find out the distance between point A on the ward to the point B on the ward, and then look at and predict the travel time. Then we have distance computation. So I have data set for my polygon. I find out the centroid, and from the centroid I did computation to find out the distance. So here the first thing is I filter out, okay, this is my source ID, this is my destination ID, source lat long, destination lat long. So I identified, and I used open source routing machine API, which returns us the result. So when I give the lat long for source and I give the lat long for the destination, it will give me the travel distance. So based on that distance, we can predict the travel time, as we have average travel time for the for from the Uber analysis. So travel times are added here. So you can see I've added everything, so they are connected. So in total, this is the in meter, the distance that would be traveled. Now, once we have this data set, now it's a regression model which we need to implement. Okay, so what we did is we filter out certain variables, and then we take out the sample. I know I'm going little quick here. So based on the sampling, I filtered out my data set. I changed it to one encoding. So I hope you all are aware about how the categorical variables are handled in a regression analysis. So the best approach is to use one hot encoding, because if you give numbers to a categorical variable, then certainly that would be giving you wrong judgment, because there would be a sequence added. So let us suppose I have some names are given, I want to give them encoding like 1 2 3. So if I give them this and make that column an integer, so certainly 4 is more valuable than 1 for the model also, because it's a linear or non-linear, it's a mathematical calculation at the end. So in such case, one hot encoding is best way to do and work on categorical variables. Once I did that, my data set is prepared. My data set is prepared. uh, and based on this data set, now I'm creating my regression model. So I'm using SkyKit to build the model. And once the model is built, I'm giving the train and train data. So what I did is I have whole set of data set. I split that into two components. One, this is called validation, and some use cross validation. So cross validation is used and is a wonderful approach by which you can actually filter out and come up with the better model, because the bias and the variance would be more adjusted when we go for cross validation. Here I have used direct validation. I have split the data set into two parts, where one is the train data. So based on this, I train my data, and then I have two accuracies. Normally, when we work on data sets, so we get two accuracies. One is training accuracy, so I predict that, and other is my test data accuracy. So that is called prediction accuracy. So why these two are important? Because these two would tell me how flexible or how biased my model is. If I see there is a lot difference between the training data, because training data is the one over which my model is actually trained, and the test is unseen data. If training data gives you 100% judgment and prediction gives you 50%, it means that your model is poorly fitted. So you need to go back and then come out. So there are huge analysis, like we need to find out a sweet point where this training data or training error and the test error, they are minimum. So for a regression analysis, as a enthusiast for machine learning, I'll urge everyone to read statistical learning book, Introduction to Statistical Learning book. This is an R, but certainly you can find there's a lot many information in Python also for this particular book. This book is a starter kit for regression analysis and for other models. So I hope if you have, you will go through this book. And if you have any question, you can ask me now, or otherwise I can stop speaking. Yeah, I thought I'm on time, uh, what was given to me. Any questions from anyone? Okay. So so you have to basically look for the repositories where you will find that data, and Isri, you have that software available with you, then it would be in a shapefile format. If you want, there are repositories out there from where you can download. But my concern, my experience with working with the Indian organizations is that such data is not available. For other data science projects, there are many data sets. Those are available. You can use for spatial. There are few data sets which we can work on. But once you will get that in data in shape format, and you can upload that to the ArcGIS. Yes, certainly, Tanya. So that's a wonderful question. Basically, spatial data, spatial domain has been added to each and every product there. So they are doing dynamic pricing based on the spatial components. As I was discussing that even the ads are being targeted. The prices are being offered on spatial, domain. Certainly, that domain is not small, so they go by North India, South India, East India, West India, but it is there. I hope I answered, Tanya, your question. Okay, thank you so much, and thank you, Sandeep sir. Thank you, Dr. Kiran Jyoti. Thank you, Dr. Pankaj Bamri. It was pleasure meeting you all and seeing such, attending such a wonderful course. I really congratulate you all. This was wonderful initiative, and we will keep working on such things. So as Dr. Sarabjot has already told, I would also like to announce that we are, as a Spod Foundation, is also going to organize a 5-day master class with the Department of Computer Science. The brochure is out, so if you are interested, you can certainly join there too, and we would be happy to assist there. Thank you so much. Thank you, everyone.
Thanks, Dr. Sujit, for such a nice and informative session. And you have very clearly demonstrated that how to use spatial data for the planning and management of the resources, as well as how to use QGIS as well as Python. Thanks a lot, sir. So if you can spare 5 to 10 minutes, then we are just having a valedictory ceremony. So please be with us for just another 5 to 10 minutes. Okay. So we're having very less time, so we are finishing up things in a very short span of time. So myself, Sandeep Kumar Singla, coordinator of this STTP, conveys sincere thanks to all the participants for their active participation in our course, Artificial Intelligence with Machine Learning and Data Science. Actually, we got 465 applications from various reputed institutes around the country. Various, like from Mumbai, applications are from there, from Mumbai, Pune, Bangalore, Jaipur, Lucknow, Ghaziabad, Baroda, so many places. I cannot even name them. So around 300 applications were eligible as per the terms and conditions by the AICTE. So approximate 100 participants have joined the course. In addition to this, few of our students of BTech and MTech who are working in machine learning and artificial intelligence, as well as in data science, participated in this course. So our primary goal from the day one was to increase their understanding of recent developments in all these 3 domains. Yet, I believe that in such a short span of time, we cannot cover all the things. But I think that this may have a little bit spark in your minds that you can excel in your projects and your research areas. So again, thanks all the participants. And now I'll invite our head of the department, Dr. Kiran Jyoti, to have a quick summary of this course. Ma'am, please.
Thank you, Sandeep sir. Sir, am I audible?
Yes, ma'am.
Okay. Coordinators of the course, Professor Sandeep Singla and Dr. Pankaj Bhamri, Project Monitoring Committee, Dr. Sujit Singh Sira, Speaker of the session, faculty members, participants, a very good afternoon to all of you and warm welcome to this valedictory session. This AICTE sponsored 1-week short-term training program on artificial intelligence and machine learning with data science is organized by Department of Information Technology from 2nd November 2020 to 7th November 2020. And the aim of this STTP was to upgrade the knowledge of faculty members, research scholars through interaction with eminent personalities from industry and academia. This knowledge sharing will improve the teaching learning process to the students and benefit the society. This STTP is attended, as Professor Sandeep has also told, it is attended by above more than 100 participants who were faculty members from different colleges, students, and industry persons. This course was started on 2nd November. And on day one, Dr. Deepak Garg, Director Leading India.ai and Professor and Head Department of CSC, Bennett University, Noida, was chief guest of the inaugural session. He enlightened the participants with recent trends in artificial intelligence, machine learning, and data science. In his keynote address, he discussed research challenges in AI in his another session. Day one ended with the expert talk of Dr. Jitendra Chabda, a professor CSC from NIT Kurukshetra. He delivered a talk on adding intelligence to engineering system. Then on day two, Dr. Sanjeev Kumar from IIT Roorkee delivered his talk on mathematics behind machine learning. Dr. Sarabjit Singh from UIET Punjab University Chandigarh had 2 hands-on sessions on classification and clustering algorithms for machine learning. Then on day three was completely managed by industry persons. Dr. Jagreet, Engineer Navdeep from Xenon Stack, Chandigarh had hands-on sessions on model ops and ML ops, making machine learning operationalized. And Dr. Mani Madhukar from IBM Research had a session on understanding IBM Cloud and IBM Watson Studio. And he had a hands-on session today also, but due to some reasons, I think participants could not utilize his time. Then first and second session of day 4 was delivered by Dr. Partha Pratim Roy from IIT Roorkee, recent applications of deep learning and brain computing interfaces respectively. Then in session 3 of day 4, Dr. Vipul Kumar Mishra from Bennett University, Noida shared his views on natural language processing with deep learning. On day 5, Dr. Durga Toshiwal from IIT Roorkee discussed machine learning for urban computing with participants. Then Dr. Amit Kamra from GNDC, Ludhiana had a session on data visualization and analysis using Orange. In the last session of day 5, last day of STTP, that is today on 7th November 2020, in first session, Dr. Sarabjot Singh Anand, Chief Data Scientist, Tartarus Data, discussed with participants how recommender system helps their users to identify the correct product or movies for them. Then Dr. Sujit Singh Sehra in the last session interacted with the participants regarding spatial data science and its importance. Thank you, Sujit sir. On a very short span, you agreed to deliver a talk. Thank you, sir, for this time. I hope our efforts helped participants in enhancing their skills with useful knowledge of AI and machine learning with data science. The researchers who are working in this field, we could help them through this STTP. Even our students who attended this STTP, they can make some effective use of it. Regarding the feedback of the course, coordinator Dr. Sandeep Singla has taken online feedback from the participants every day, but still I request the participants, if somebody wants to share their experiences, they can unmute their mic and they can share their experience. Anyone from the participants?
Hello, ma'am.
Yes, hello.
Yes, ma'am. I would like to present my feedback. Okay. Hello, everyone. This is Divya Joy Singh. Firstly, thanks to all, and especially to the course coordinators and the professors and doctors for providing this wonderful platform where I got a chance to learn something new rather than, I must say, an interesting stuff. AI, ML, and data science are itself fantastic topics, but the professors and doctors and some company representatives made it even astonishing. So thanks to all.
Thank you, Juhi. Anybody else who wants to share?
Good afternoon, ma'am. Good afternoon, ma'am.
Good afternoon.
My name is Anant Sri, and I am from a third year IT branch. I would like to present my feedback on the course, one week program on artificial intelligence. The course does an excellent job in touching the concepts of each major ideas in the artificial intelligence, including the backgrounds for non-programmers as well. Because the technology doesn't depend on a programming skills only, but it also depends on the concepts like soft computing, the layout behind the artificial intelligence, as well as the IBM cloud. So the most interesting thing for me was the soft computing and the brain computing, and I love to enjoy this session, and I will looking forward to develop the more project ideas using artificial intelligence. Thank you, ma'am.
Thank you, Anand. I was looking at, you were attending all the sessions. Very good. I hope
Thank you,
you will
ma'am.
do something in future with this
Thank you,
STTP
ma'am.
knowledge.
Thank you, ma'am.
Good afternoon, ma'am.
Good afternoon.
Good afternoon, everyone. I'm Jasleen Kaur of IT Department of Guru Nanak Dev Engineering College, Ludhiana. I would like to thank all the faculty members of my college for giving us a chance to interact with prominent and intellectual personalities of India. The workshop was very interactive, which profited all the participants enormously. Artificial intelligence, machine learning, and data science is a very important topic nowadays. There were many examples which made it really easy to follow and understand this topic. This workshop has been very inspiring, and I'm really feeling delighted to have been able to be part of this. Thank you.
Thank you, Jasleen.
Hello, good afternoon, ma'am.
Good afternoon.
My name is Nikhil Sood. I am currently the student of second year in the BTech of IT department. I may like to express my sincere thanks to Dr. Sukhjit Sehra for giving an excellent coverage to his lecture. I also wish to express my gratitude to you as HOD of our college for providing encouragement in the field of artificial intelligence. I am also very grateful to my professor Sandeep Singla sir for motivating me to join this series of wonderful lectures of artificial intelligence. I am now able to see it from completely different perspective. I'm very happy to be part of this 1 week program of our college, and I am very happy as I am a student of GNDC Ludhiana. I have enjoyed it so much in this time of COVID pandemic. Journey started from very starting beginning, like from Dr. Deepak Garg, as he introduced us to artificial intelligence, and then to this day of artificial intelligence. It was very, very wonderful. So thanks for motivating me to be a part of this series. Thank you, ma'am.
Thank you, Nikhil. Anybody else from any other institute want to share the feedback? Any faculty member?
Hello, madam.
Hello.
Hello, madam.
Hello.
Yes, we are listening. Yes, sir, Rajendra ji, you can speak.
So you're audible.
Sir,
This side from Panipat Institute of Engineering and Technology, Samalkha, and I would like to tell that I was a student of AIMTech there at GNDC Ludhiana from 2005 to 2009 batch, and I'm very happy that due to this pandemic, the virtual FDPs are being conducted, and I am very much thankful that I'm a part of this FDP, and happy to say that I met here my teacher Amit Kamble sir was there at that moment when I was a student, and Pankaj Bhamri sir was my senior at that moment. And would like activities should be conducted in the near future, and I will definitely attend that. And the sessions we did here was very practical and would say effective for us. Dr. Mani's session I attended at PITE also. He visited to us at PITE, and IBM Cloud and other things were discussed over there also. So I'm thankful to organizers, sir, and all the team who has contributed directly or indirectly to this activity. Thanks to one and all.
Thank you, Rajendra. You were very interactive participant in all the sessions. Thank you. Anybody else?
hello.
Yes.
Good evening, madam. I'm Rajendra Kumar Math. I am from Karnataka, and I am very happy that I was a part of this particular FDP. The mainstay of what I feel like the mainstay of this STTP was the resource persons. Really, the resource persons that you were able to get were highly motivated, and they were able to guide the participants in like we do to our students. Definitely, I think that has made this STTP to stand different other STTP that I have attended. And I hope the same thing continues in the future too, and looking forward to your college to provide such facilities to our other faculties also. Thank you, madam.
Thank you, Rajendra sir. Your words are really motivating for us for another courses also, so that we can continue our job in this way.
Thank you, madam. Thank you.
Any other?
I think they are waiting for the test.
Okay.
Test will start at 3:40. Now I request Dr. Pankaj Bhamri to quick word of thanks. Dr. Pankaj.
Good afternoon. The project monitoring committee members, head of department, Dr. Kiran Jyoti, Professor Sukhjit Singh Sera, my dear friend who has worked here for numerous number of the years. We have the close memories associated while working with each other. And Professor Sandeep Singla, the coordinator of this program, and my dear participants. So this is a formal thank, but I do acknowledge that the satisfied participants do give the feedback in the form of that we have moved in the right path. So while initiating about this course, while choosing these topics, AI, ML, and data science, we have identified that these are the fields which is in demand, on which the numerous research could be performed, and there are huge number of the opportunities for the practitioners. So while identifying the exact need, we have finalized this topic and proposed to the All India Council for Technical Education. And we are grateful to the principal, sir, that they have always given us the opportunities to work for the betterment of the institute and the society as well. So one thing I want to add as the acknowledgement, that whenever you are working hard, then you are able to recognize that these are the true efforts that you have performed. But whenever you are working with a team who is performing the sincere attitude, sincere efforts towards while understanding the individual responsibility to bring the better results, then I feel uh, uh, you feel like you are blessed to have be part of such team. So at this moment, I do believe that I'm being blessed to be part of such a good team, where Dr. This is not the right word, doctor, but he's just submitted his PhD thesis in the IIT Roorkee. So Professor Singla, he has worked very hard for the successful attainment of the objectives of this course. So whenever Professor Singla is being attached with any team, so the success is being granted. So with the noble guidance of Dr. Kiran Jyoti. So it is very good to know about the successful attainment of this course with the feedback of all the participants. So once we have initiated this task, we were believing that 6 days is a huge period. We put the effort that it should be of 5 days duration. But as per the AICTE norms, the 6 days duration was the essential component. But with the involvement of the blessed pupil, the resource persons, excellent resource persons, with the effective efforts of the team members, with the due involvement of all participants, if there is no significant participation by the sincere participants, no course could be successful. So all the participants have regularly, sincerely has involved with such planned events, and this is the major reason for the success of this course. So with the involvement of all these issues, I don't recognize how these 6 days has been passed. So in future, I invite all of you to visit the campus. This is a lush green campus here in the center of Punjab, having a historical background. It was started, our campus was started in 1956, and we are offering various courses initiating from the Polytechnic Diploma to the PhD level courses. So in future, after the pandemic scenario, so if possible, I welcome you all for such kind of the events that we do propose in future for academic growth of one and all. So I thanks everyone, initiating from the authorities, management, my team members, the team members who have worked very effectively, Professor Singla, my head of department, Dr. Kiran Jyoti, the lab superintendent, Amandeep Singh Patel. So all the members have worked perfectly to give the fruitful results. So I'm grateful to everyone, as well as the core team, that is the participants. So I'm thankful to everyone to bring a successful result of this effort. Thank you, everyone.
Thanks, Pankaj sir, for your nice words. And now I think all the participants are waiting for the reward, like they want to prepare for the test and they want to earn a certificate. So at last, I'm thankful once again for your comments and suggestions during the STTP, and I expect the same kind of support and association with you in the near future also. And one new announcement for you, that this course is, we are again repeating this course in from 2nd December to 7th December, with the same title. Okay, anyone known from your side, or any other person who may to wish to join this course can join. And one more course is in second from this 9th November to 14th November on cybersecurity. I think most of you are knowing about this. So I request you to join that course also. So now at last, I'm again thanks to all of you and wish you all the best for the test. Thank you. And thanks, Dr. Subjit, for sparing valuable time for this session.
No. Thank you so much. And it's really like, the words said by participants they mean it. And you guys really worked really hard. And I congratulate the department, Dr. Kiran Jyoti, you, Dr. Pankaj. Certainly it is awesome course. Thank you and congratulations to everyone. Thank you. All the best to the party for the exam. Yeah.
Thank you, Sujit sir. It was really nice to have you.
Yeah. Same here, ma'am. Reciprocating.
Okay. Okay, participants, all the best for your test.
So I'll be sharing the link within 5 minutes in WhatsApp groups. Okay, anything else participant want to share? So thanks all. So I'm sharing the link within 5 minutes in the WhatsApp group. Yes, Pankaj sir, we are going to launch this STTP again from 2nd to 7th December. The dates are same, but the month is December. Resource persons, mostly 80% of the resource persons will remain same. That depends on their availability, and we'll try to keep the same resource person. Yes, you can leave meeting, Shiva Kumar, you can leave meeting. I'll be sharing the link in the WhatsApp group. Ratan Deep is asking for link for FDP starting from 9 December. We'll share this link on our website, gndc.ac.in. So, okay, thank you.